All right. So in the previous class, what we have seen is, students, we were discussing about double integration method. So double integration method is integrating the elastic curve equation two times to get the slope and deflection. So if you do integration once, we will get slope, and if you do integration twice, we will get deflection. So we were discussing about different types of loads on a cantilever beam, and we are solving for deflection and slope. Okay, this is what we have seen in the previous class. So we have seen three different types of loads on a cantilever beam for which we have solved slope and deflection. So those three are point load at the free end. So the first condition that we have solved is, we have taken a cantilever beam and we have assumed a point load at the free end. Okay, and we have solved for deflection and slope. Okay, and second condition is, we have considered a uniformly distributed load throughout the length of the cantilever beam, and we have solved for slope and deflection that we have seen in the previous class only. And third condition, third kind of loading is, we have assumed a movement at the free end. We have assumed a movement at the free end, and we have seen that also. And now we'll move on to the fourth condition, fourth kind of load, students. So fourth kind of load is nothing but, students, we are assuming a cantilever beam. Okay, we are assuming a cantilever beam, and we are assuming a uniformly distributed load to some extent starting from the fixed end. Okay, from the fixed end we are assuming a uniformly distributed load only to some extent. Okay, let me say up to B, and the beam length is up to AC. Okay, so if this is the condition, how can we write slope and deflection? That is what we are looking into. So let us say this distance is A, students, small a, and length of the beam is L. Okay, so we have this kind of load. So if you have this kind of load, how do you write slope and deflection? How do you write slope and deflection? That is what we are looking into, students. So we have from the second condition, students, all of you please refer second condition. Second condition is a cantilever beam with uniformly distributed load at a throughout the length. So up to B, if you consider beam only up to B, students, okay, let us consider the beam. Let us consider the beam only up to B. If this is the beam and this is the length of the beam, so what will be the deflection? We have already solved this. That is, what I mean to say is, deflection at B, YB is equals to this. We have already solved, students, and we have got this as WA power 4 by 8EI. I hope you have remembered this. Please go back and see this. This is for second type of load that we have solved. And we have also seen this, students, dy by dx of B, that is theta B, is equals to minus WA cubed by 6EI. Okay, we have seen these two things. So we have got a deflection at B. Now we would like to find out deflection at C. Okay, so if you see here, if you see the elastic curve of this deflection, students, see, I'll just mark it with red color pen. So it will deflect like this. Okay, it will deflect like this up to here, and it will go as a straight line up to C. Okay, the slope will remain common. So the slope varies only up to AB, and the slope from B to C remains the same. I hope you got this. As there is no loading between B and C, as there is no loading between B and C, the slope remains same from B point to C point. So B to C is a straight line, whereas AB is a elastic curve, where we can observe the change of slope because of the uniformly distributed load here. Okay, and whatever the slope is here, that is theta B, will be equals to, so we can write a point like this, students, as BC has no loading, the deflection curve, the deflection occurred at B due to UDL will remain, and elastic curve continue as straight line, okay, up to C. So what does this point say, students? So what is it saying, students? Theta B is equals to, so we can write theta B is equals to theta C, that is slope at B and C is same. Okay, students, I hope you got this. Why I have written it same is because of this, WA cubed by 6EI. Alright. Now we would like to find out deflection at C. So what is YC, students? We would like to find out YC. See here, the deflection will be like this, right? See, this portion, if you take this portion, I'll just mark it with a dotted line like this, and this part is nothing but YC, right, students? So this part is YC, and here this part is YB. We have just seen this, students. This is B point, and this is nothing but YB. YB in the sense deflection at point B. YC is deflection at point C. So we would like to find out what? We would like to find out what, students? We have to find out YC. See here in YC, so this is all YC, right? In YC up to this portion it is YB. Am I right? Am I right? See here, I have marked the dotted line here. Up to this dotted line, this is nothing but YB, right? So YC becomes YB plus YB plus, I need this portion now. What? Which portion, students? I need this portion. Okay. So this is YB plus this portion. What is this portion, students? Here we have got theta B. Okay. Here we have got theta B, and this length is L minus A. Am I right? This dotted line length is L minus A. So I just wanted to take it as a triangle for your sake, students. Okay. So I would like to find out this is L minus A. Okay. And I would like to find out this length, students. So for getting this length, I can write it as theta B into L minus A. Am I right? Theta B into L minus A to get the length of this. So YC is nothing but YB plus theta B into L minus A. So substitute the all values of YB and theta B here. You will get this, students. YC is equals to, I am just making minus as common, WA power 4 by 8 EI. So this is YB value plus theta B value is WA cubed by 6 EI. So I have taken minus common, so minus remains outside. This is L minus A. It remains. Is it clear, students? Is it clear? Any doubts here? Students, please let me know if you have any doubts here. Manikant, Lakshmi Mukesh, Keshav Sai.
Sir.
Is it okay?
Sir.
So Lakshmi Mukesh and Manikant, what are you doing? Are you there in the class? Manikant? Ashok, Gaddam Ashok. Hmm. All right, students. So this is cantilever beam with UDL to some extent, starting from the fixed end. This is fourth kind of load that we have seen, and we'll see some another load, students. So let us try to solve for fifth kind of load, students. So fifth kind of load is we'll assume the same cantilever beam. Okay, cantilever beam with UDL with UDL to some extent to some extent starting from free end. Okay, so in the previous case we have seen from fixed end, here we are seeing from free end, starting from free end. Okay, so I just wanted to write it, represent it graphically. So this is our UDL, and we have this kind of part like this. So how do we solve if we have like this? So this is A, and this is B, and this is C. So how do you solve, students? This is nothing but L. Okay, and this is L, and let us consider this as B, students. B. Okay, and what does this becomes? L minus B. Is it clear? So if you have this kind of UDL, what we'll do is we'll consider a UDL like this, and we'll consider another UDL like this. So the above UDL and the below UDL will get cancelled, right? Am I right, students? I hope you understand this. The question is we only have UDL to some extent. Okay. The question is we only have UDL to some extent starting from the free end. So if you come across this kind of problems, what we'll do is we'll assume a UDL to make it UDL throughout the length, and to cancel this assumed UDL, we'll assume another UDL at the bottom. Is it clear? Up to here only, up to B only. So now let us try to solve this, students, how this goes on. Uh, let us take this. Now consider UDL. Consider UDL as shown, and solve. So let us write for UDL above. Okay, UDL above ante paina unna UDL mottam ki ani, because of the UDL acting on above the B. So what will be YC? Okay, YC ante deflection at C. So YC above అని రాస్తా నేను, just for our reference. YC above is equals to this. We have solved, students. ఇట్లా మొత్తం UDL ఉంటే మనకు తెలుసు, ఆల్రెడీ మనం సాల్వ్ చేస్తాము. And what that equation is WL power 4 by 8 EI. మీరు కావాలంటే సెకండ్ టైప్ ఆఫ్ ఎగ్జాంపుల్ ని రెఫర్ చేయండి. We have already seen this. Now UDL below చూద్దాం. UDL below అంటే ఓన్లీ బిలో కన్సిడర్ చేసుకుంటే, ఓన్లీ అబోవ్ కన్సిడర్ చేసుకుంటే deflection at YC we have got. Only below, if you consider only below, what will be YC, students? YC below. దీనికి కూడా మనం ఇందాక ప్రాబ్లం కన్సిడర్ చేసుకున్నాం. ఇందాక ప్రాబ్లం కన్సిడర్ అంటే ఈ కన్సిడరేషన్ కి ఏంటంటే what I am assuming is I am assuming only UDL to some extent. Okay, in the previous case we have solved this same. ఇదే సాల్వ్ చేస్తాం మనం ఇందాక ప్రీవియస్ కేసులో. సో UDL below in the sense you consider only below one. Okay, and leave this part. So UDL above in the sense you consider the entire UDL which is above. Okay, I have written YC based on this condition here, and I have written YC based on this condition here. I am about to write. So ఇది ఇంతకు ముందే సాల్వ్ చేసాం కాబట్టి we can write ఈ లెంత్ A is L minus B here. పైన A అని వచ్చింది మనకు, ఇక్కడ A ప్లేస్ లో L minus B ఉంది. So W into L minus B whole power 4 by 8 EI plus w into L minus b whole cube by 6 ei into L minus b. అంతే కదా. పైన ఈక్వేషన్ చూడండి, నేను పైన ఈక్వేషన్ ఒకసారి చూపిస్తాను మీకు. ఓకే, ఆల్ ఆఫ్ యూ సీ దిస్ ఈక్వేషన్ స్టూడెంట్స్. హౌ ఇస్ దిస్ ఈక్వేషన్? ఏ ప్లేస్లో L minus b సబ్స్టిట్యూట్ చేస్తాను అంతే నేను. సో ఏ ప్లేస్లో L minus b, I have substituted L minus b in place of a. Okay, this is yc below. సో ఇఫ్ యూ సింప్లిఫై దిస్, మైనస్ ఎక్కడ పోయింది సార్ అంటే, మైనస్ ఎందుకు తీసేసిన అంటే ఇది బాటమ్ సైడ్ ఉంది కాబట్టి, udl is acting below, so I have taken off minus. So if you simplify this, yc below will become w into L minus b whole power 4 by 8 ei plus w into L minus b whole cube by 6 ei into, here I would like to cancel off L. Okay, L ని క్యాన్సిల్ చేసేస్తే ఏమవుతుంది, L minus L plus b అవుతుంది. సో b ఉంటుంది అంతే, జస్ట్ మల్టిప్లైడ్ బై b. ఓకే, so this is yc below. Now what is our requirement students? Deflection at point c if we consider both the conditions. Okay, ఇప్పుడు ఏం చేస్తామంటే ఒకసారి ఒక కండిషన్ ఇంకోసారి ఇంకో కండిషన్ అజ్యూమ్ చేసుకున్నాము. ఓకే, డిఫ్లెక్షన్ అట్ సి ఇఫ్ యూ కన్సిడర్ దిస్, ఇది కన్సిడర్ చేస్తే ఎట్లా అని, ఇది మొత్తం కన్సిడర్ చేస్తే డిఫ్లెక్షన్ అట్ సి ఎట్లుంటుందో చూస్తాం. సో yc ఈజ్ నథింగ్ బట్ this minus, so yc above minus yc below చేయొచ్చు కదా. ఇప్పుడు ఈ మొత్తంని ఇది మైనస్ చేసేస్తా, అప్పుడు నాకు ఈ పార్ట్ వస్తుంది, డిఫ్లెక్షన్ బికాస్ ఆఫ్ దిస్ పార్ట్ వస్తుంది. సో ఐ విల్ డూ దిస్ స్టూడెంట్స్. ఓకే, so this implies yc is equal to what happened. Okay, this implies yc is equals to minus wl power 4 by 8 ei minus w into L minus b whole power 4 by 8 ei plus w into L minus b whole cubed by 6 ei into b. This is what our answer is. Now let's students, similarly we can do it for theta. Theta ఏమని రాయొచ్చు మనము, slope at c. Slope at c. So dy by dx of c is equals to minus wl cubed by 6 ei. This is slope at above if you consider above, minus slope if you consider only below, 6 ei. So this is what the answer is. Okay, is it clear guys? Is it okay?